Now let us discuss the last example of this convolution theorem, that is find the inverse Laplace of s plus 2 divided by s square plus 4s plus 5 the whole square by convolution theorem. So as I told you, you have to split this in terms of two functions. One is f of s and g of s. So first function I used to define like this: s plus 2 divided by this one term. Out of these two I have taken here one term, and another one term I used to take in a second function, that is g of x. Now your aim is to find the Laplace inverse of this one, Laplace inverse of this one. So let us go for Laplace inverse of f of s, that is Laplace inverse of this term. Okay, so as I told you, it is in the form of a perfect square. You have to split this in a perfect square. If you want to do in a rough, I will show you, that is how you can do this in a perfect square. Okay, so as I solved in the previous examples also, x square plus 4s plus 5, this I used to write like this: out of these two you have to take 1 plus coefficient of s is 4, half of that one, square it, plus this term as it is minus the square of this term is 4. So s plus 2 the whole square plus 5 minus 4 is 1. So I can write this one as like this also, 1 square. So this term you can split in terms of s plus 2 the whole square plus 1 square. Or so therefore I have written like this. This is s plus 2 as it is, and s square plus 4s minus plus 5. This can be splitted in the terms of like this. Okay. Then as you know that s plus 2 is there, s plus 2 is also there. So therefore you have to shift a property, okay, by using the first type of the examples. Okay, so replace, you can write here also, replace s plus 2 as s. Okay, so if you replace, you have to write down here exponential. So e raised to opposite sign of this one is minus 2t. Laplace inverse of replace s plus 2 as s, replace s plus 2 as s, this one. E raised to minus 2t as it is, Laplace inverse of this one is cos t, you got f of t. Similarly, you go for the second, Laplace inverse of this denominator. Okay, you make it a perfect square by using the same as I did in the f of s. So therefore the perfect square is given as s plus 2 the whole square plus 1. And replace s plus 2 as same, s plus 2 as s. If you're replacing, so you have to take an exponential e raised to minus 2t, Laplace inverse of this term. Okay, where s is replaced, plus 2 is replaced by s. So it become 1 divided by s square plus 1 is sin t. So you got g of t. After getting f of t and g of t, you have to use the convolution theorem. Convolution theorem. The convolution theorem. Now apply the convolution theorem. We have the convolution theorem is like this. You have to find the Laplace inverse of s plus 2 divided by s square plus 4s plus 5, and the convolution theorem is stated as like this, that is e raised to f of u and g of t minus u. So substitute this one here. So I have written here, I have splitted this term e raised to minus 2t, e raised to minus of minus plus 2u. Okay, this term as it is, this you multiply this here, this is sin t minus u as it is, cos u with respect to du. Okay, now see here, e raised to minus 2e, u raised to plus 2e, it becomes 1. So therefore I have left over here e raised to minus 2t as it is. Okay, this sin t minus u cos u with respect to du as it is. Okay, and you apply here sin of a minus sin a into cos b. There is a formula, sin of a plus b plus sin of a minus b. There is a formula I have applied here, minus u plus u get cancelled here. So therefore this 2 I have taken outside, e raised to minus 2t divided by 2 bracket sin t plus sin t minus 2u with respect to du. Now integration of sin t with respect to du, it is a constant. So 1 with respect to du is u, applying limit 0 to t. Plus here it is a function here, sin of t minus 2u is minus cos of t minus 2u divided by differentiation of minus 2u is minus 2. So bracket applying limit 0 to 2. This term as it is, sin t as it is, apply upper limit minus lower limit plus. So minus into minus it becomes plus. So plus as it is. So cos of, so I have taken 1 by 2 outside. Cos of wherever u is there, you replace by t. So cos of t minus 2t is cos t minus, if you apply 0, so it becomes cos t. So cos t minus cos t become a 0. Okay, only remains sin t into t or t into sin t, this term. So this is the solution for the given function by convolution theorem here. Okay, so I hope you have understand these all examples, 5 very important examples You may get this type of examples in examination. Most of the examples they used to ask in the form to find the given function inverse Laplace transform by using convolution theorem. So verification they used to not ask in the examination. So be prepared for these important 5 examples. Either you may get the different type of examples in also by taking different function. So you can follow this type of examples. I hope you have understand this one. Now in the next video lecture or video class, the last concept of this model is or inverse Laplace transform is that is having the inverse Laplace transform of the differential equations. Okay, linear differential equations. I used to deal in the next class. Okay, thank you.